Hello, everyone, and welcome to the February 22nd, 2025 online viewing session for the Kalamazoo Astronomical Society. I assume everyone can hear me and we're ready to go. Going to make a few changes to my settings here. That's much better. I prefer the gallery view as opposed to the other view. So hopefully the old voice holds out. Before I give you some info on the telescope, let me give you some info on me. I've been down with the flu all week long. Tuesday I could barely talk, so today we'll see how far I get before the voice gives out. My legs are really rubbery, but thank goodness we can do this from the seated position. Otherwise, I would die. But otherwise, I think I'm going to be able to hold out pretty well, which is great because it's a fantastic night at Arizona Sky Village. So without further ado, let's just jump right into it. I'm going to go back and share the old screen here, and we're going to get right going because we got a lot going on here tonight. Now, normally, if you've joined us in the past, you know during the session, I always try to do one or two new objects, two deep sky objects that we've never done before. But with me being sick all week long and just no energy to do much of anything, I figured tonight we're going to do some of the classics of the past. So we're going to do the really, really cool stuff. I mean, sometimes I try to do new stuff and people are like, hmm. So tonight we're not going to get any of that. We're going to get all oohs and ahs. So um, let's begin by giving you just a quick little tour. This is Piishi Observatory, which is Apache for Nighthawk. It's a 20 by 20 roll-off roof observatory owned by KAS member Mike Patton at Arizona Sky Village, which is located kind of in southeastern Arizona, not the extreme southeast portion of the state, but kind of southeast, but a little more north, very close to the New Mexico border. And within this observatory is four telescopes, but the one that we're concerned with is the one kind of peeping up right there. That is the KAS Remote Telescope. You can see our 20-inch, and you can just barely see the Takahashi there. So it's the biggest telescope in there. The rest are pretty much small refractors and maybe kind of one decent-sized Schmidt-Cassegrain. And you can see on the side here, we have our weather station. We'll give you a weather update later. But the main thing we always deal with at this point is this little box right there, which is our all sky camera. So this is the Piishi all sky camera. This is our second camera that we just started using new this season. And we put it in last June or so. And it's much, much better than the old S-Big camera, which had a very tiny CCD. But now we got a big old CMOS chip. Well, it's big compared to the old one. So we use a ZWO ASI 138 no, 183. I guess I got dyslexia, but it's a ZWO ASI 183 MC color camera. And they do come with, a little fisheye lens, but we want nothing but the best for you folks. So we upgraded to a Fujinon 2.7 f1.8 fisheye lens, which gives really great images. And we use something called All Sky Eye to control it. It's a weird spelling. So let me show you what the All Sky camera is currently showing us after I let a few people in. So go to the web browser here, wherever it is. There it is. And there is the current sky above Arizona Sky Village. So it is crystal clear. So let's give you a quick tour of the currently visible planet and constellations. We still have the planet parade going on, as it were. The really brilliant thing in the sky that you can see is Venus over here. That looks like it's almost due west right now. You can even see a bit of the zodiacal light, basically dust in the plane of the solar system that reflects sunlight. It doesn't quite show up as well on the newer camera because we still need to maybe calibrate the background a bit and darken it a bit. So zodiacal light stands out a bit better like it used to with the other camera, which had a bit of a darker image, which really helped enhance the zodiacal light. And we do have a couple other planets. We got Jupiter, still hanging out in Taurus, and Mars is now really ensconced in Gemini there. Last month, I think they were pretty much right in a row, or they at least made like a letter L shape. But now Mars is right in there, past opposition, but still in pretty decent viewing. I unfortunately haven't been able to get out to see it myself this season, but we at least have three planets. I think Saturn is pretty much gone now. So there's the current reign of planets. And for autumn constellations, I think they're pretty much gone. Um, this is Andromeda. So there we go. That gives me some reference. So these two arcs of stars form the constellation Andromeda, and we're pretty much missing the Great Square now. So we are definitely well into winter since we're losing those autumn constellations. So let's focus on the winter constellations since those are the ones that are currently dominating the night sky here on a kind of early February evening. We'll begin with the biggest one in the sky, the most popular one in the sky, Orion the Hunter. And of course, Orion's really easy to identify. It's probably the most identifiable of all the constellations. But if you're very new, very green, just remember three stars in a row, two above and two below. So remember that little limerick, and you cannot forget what the constellation Orion looks like. I mean, if we made a constellation from scratch, we could not make a better one than Orion the Hunter. So, of course, the three stars in a row are his belt, Alnitak, Alnilim, and Mintaka. And then above we have his shoulders, Betelgeuse and Bellatrix. And below we have Rigel and Saiph, Saiph. So if you take some Betelgeuse, your belly will do some tricks, but if you take some Rigel, you'll be safe. So we got the belt stars, the shoulder stars. These are his legs. He has a little tiny head above his shoulders, so big guy, but not terribly bright. Very, very tiny head. He has a curved arc of stars for his shield. He's holding up a club up toward Gemini here. And then, of course, hanging from his belt is the famous sword in Orion. And we're going to spend some time around this area of the sky tonight because we haven't looked at him yet, and we look at him every season. So tonight's the night. If you don't know what I'm talking about, well, we're going to keep you hanging because it's pretty cool. So Rigel here is the first corner of the winter hexagon, a giant asterism that we can use to basically find all the major stars and constellations of the winter. Going from Rigel, we go upward, or you can use the belt stars here to go up into the right to Aldebaran, which marks the eye of Taurus the bull. And right near Aldebaran, we have this V-shaped cluster called the Hyades. Aldebaran is not a member of the Hyades, but I believe it's a background star because the Hyades is one of the nearest clusters. So I think Aldebaran's more distant than the Hyades, but you can correct me if I'm wrong. You know, no one knows everything. But this is the face of Taurus the bull. And there's a couple ways you can draw Taurus. Sometimes it just has like a straight line of stars, but if you do it really right, you can kind of make a little leg here and a leg here, like he's charging through the sky. And of course, there's Jupiter, kind of like a bright thing on his head right now. And then we have the Pleiades up there, and we checked out the Pleiades with the Takahashi earlier this season, but tonight we're going to get a close-up of one of the stars with the big scope, and that's pretty cool. So we go from Rigel to Aldebaran to Capella, and Capella is the goat star because it's in the constellation Auriga, the charioteer, who is for some reason making off with someone's goats. So we have Capella, the goat star, and this little triangle of stars here, this little tiny triangle, those are called the kids. And again, why he's stealing goats, nobody knows. And the throat is given out, so gotta lubricate it here. Give me just a second. So the L shape here is the chariot, and then this is the head of the charioteer. So he's kind of riding off in this direction with somebody's goats. So then we go from Capella to Castor and Pollux, but Pollux is the brighter of the two, so that's really kind of the corner of the hexagon, but sometimes people do both of them. And these are the Gemini twins, of course, Castor, Pollux. And Castor has this long neck with these kind of longish arms, a long body, and these little bitty stick legs. While his brother Pollux has these short little arms. They're holding in hands here, so kind of like arm here, arm here. And he has the short little body. Whoop, give it a chance to reload there. It reloads every 4 minutes. And then we have these kind of bull legs here, these long bull legs. So they're twins, but they're kind of posed maybe a bit differently. Then we have the star Procyon, and if you're a student who's tasked with drawing the constellations of the winter, this is your favorite because you just have to sketch Procyon and go Misa here for Canis Minor, and that's it. It's just two stars. Very silly. And then we go down to the brightest star in the night sky. So compare Sirius, the brightest star in the night sky, with brilliant Venus over here. I mean, this is magnitude about minus 1.4, 1.5. This is probably somewhere around minus 2.5 right now. So big difference between the two. Remember, for every 5 magnitudes, it's a intensity ratio difference of 100. Magnitude scale is a logarithmic thing, but we won't get into that tonight. So one way to draw the dog is with a triangular head here, where Sirius is the nose, and then you just draw a stick dog. There's like a body with a leg here and a leg here, and you can give him a little short tail, or I like to give him a curvy tail sometimes, like a big old husky dog. I mean, it is the wintertime after all. And we're getting some early previews of the spring constellations right around here. You can't really see it. You can see our final target with the Takahashi right there tonight. This is the constellation Cancer the Crab, which is really hard to see between Gemini and this figure here called the Sickle. So this is another asterism, kind of the dominant asterism of spring. And this is what we call the Sickle, which is marked by the bright star Regulus. But this is the mane and head of Leo the Lion. And you can just see his triangular body. Now, this is the nebula. So we're just now getting the entire constellation of Leo the Lion. And also just rising is Ursa Major, or this famous part, the Big Dipper. And we will end our night with a galaxy kind of over in this region here. So that is a current tour of the winter sky. And just a quick update, we are now at a full house. So let's check in on the weather. So looks like, of course, it's clear. We can tell that for ourselves from the all-sky camera. Fortunately, the wind is very calm. It's only 2.9 miles per hour right now, which is good because if it does get to 10, a nasty alarm's going to go off in my head, and then everything will shut down because 10 miles per hour is our maximum. Things just get too shaky, especially with the big scope when the wind gets that high. And normally I change the upper limit of the wind to maybe 20 miles per hour so we at least don't get interrupted, but I forgot to do it, but I think we'll be okay. And the humidity is only 20%. It's about 53 degrees Fahrenheit. Makes me look forward to Wednesday here in Michigan when we get up to 47, even though it's supposed to be a rainy day. And this screen that you're looking at here, this is the computer in the warm room of the Piishi Observatory. So this is the computer that's directly linked to the remote telescope. It's a direct connection. And so, of course, we have our Clarity weather station. M1 Oasis is what controls the roof. The big screen here in the middle is Maxim DL, which controls the auto guider and the camera. And this is ACP that controls all these other programs via a web interface that you'll see a lot here throughout the night. And I think I still have it on. There we go. So we'll pop this up there. And here is a live view of the KAS Remote Telescope. So you can see the flip flat, or the cover of the Takahashi, is open because that is the scope we're starting with tonight. So let me introduce you to that. So yes, the first scope that we always start with is our Takahashi FSQ 106 EDX3. I'm not going to bother to read off all this here. I'll let you do it because I've done it several times this season. But in short, it's about a 4.2 inch refractor with a 530 millimeter focal length. And you'll notice we no longer have the stock focuser, but we use a Moonlight Nightcrawler 2. Very, very excellent focuser. And on the back is our camera. We have actually two of these, one in each telescope. We're still using an SBIG STX 16803 CCD camera, but with any luck, by the time we start next season, we'll have all new cameras on the two telescopes. But it depends on how well our upcoming fundraiser does. So maybe I'll mention that later, but don't worry, I won't hit you up for too much money tonight. Well, probably none really, but you get the idea. So it's a full frame camera, um, basically a 37 millimeter square chip. So it's a really, really big chip, about 4,000 by 4,000 pixels, or 4,100 if you want to round up, which is nearly 17 megapixels. So CCDs are kind of on their way out, like, DSLR cameras are as well, even though DSLRs use the more modern CMOS sensors, but CCDs are pretty much on their way out. There used to be really no difference between the two, except CMOS cameras were easier to make, or at least the chips were easier to make. So now, because they are cheaper, they've been throwing all their research into CMOS. So really, in recent years, CMOS has pulled ahead of CCDs in terms of low noise and resolution and stuff like that. But it's still a really, really excellent camera. Okay, so let's go to our first target of the night. And to do that, I got to go back to the web browser. Which one's the web? They keep moving the position of the web browser there. There we go. So here is the web interface for ACP. And let me pop open the image from last night, because I was messing with our new version of Focus Max, and I took this image with the Takahashi last night. So I know you guys can't unmute yourself right now, so maybe throw it in the chat. If you know your deep sky objects, or your areas of the sky, we'll kind of have a little game here. What area of the sky is this? So hopefully all the galaxies kind of give it away. So there you go. Let me know if you know what this is in the chat, and we'll confirm that later. Okay, so I already have our first target of the night entered in there. I'm pretty sure. I think 5 minutes will be good. So let's go ahead and fire that off, and we'll get this set up for you. So yes, I typed in IC 434, but specifically we're going to focus in on B33, or Barnard 33, the Horsehead Nebula. But there's going to be a lot more visible in this image besides the Horsehead. So this object has a pretty rich history. The nebula was first recorded on a photographic plate in 1888 by the Scottish astronomer Wilhelmina Fleming at Harvard College Observatory. So here's an image of her. She's the one standing in the center. So Edward Pickering, who's visible on the left there, claimed that his maid could do a better job of identifying and cataloging the observatory images than his male staff. So he did hire his maid, Fleming, along with several other women who became known as his computers. They did the routine calculations and measurements from photographic plates, and many of them made many, many discoveries. Like Henrietta Swan Leavitt, came up with the period luminosity relationship for Cepheid variable stars. Annie Jump Cannon helped develop the spectral sequence of stars, and just so much more. So, but Wilhelmina Fleming here on a photographic plate was the first to notice what we now call the Horsehead Nebula. So, of course, the Horsehead Nebula is in the constellation Orion, just hanging off the star Alnitak. It's about 1,375 light years away, as is much of the nebulosity in Orion. And the nebula that surrounds the Horsehead is pretty large. So to really take in the entire scene, it is best to do with the Takahashi. The 20-inch can get us up close to the Horsehead itself, but the Takahashi gives you a good feel for what the area is like up close if you've never really seen it before. So, in addition to discovering the Horsehead, Fleming discovered 58 other gaseous nebulae, 10 novae, and more than 300 variable stars. She became the first American woman to be elected an honorary member of the Royal Society of London. And photographing this region in 1894, the legendary Edward Emerson, or E.E. Barnard, described it as a dark mass, diameter 4 arc minutes, a nebula strip extending from Zeta Orionis, or Alnitak. So the Horsehead, it's very difficult to see. I have seen it through a 36-inch telescope very clearly, but through smaller telescopes, I've struggled around at least the moderately light polluted skies we have around here. But as to where to look, it's really easy to get to that part of sky that sky, of course, because it hangs just off Alnitak here, the lower star in Orion's belt. And we'll zoom into a close-up here. And for the close-up here, I always use Sky Telescope's Jumbo Pocket Sky Atlas, which you can purchase from their store. I highly recommend it. So I always like to give them a plug because I sort of, borrow the images from their atlas here. And you can see this little notch in the nebula there. And sure enough, that is where the Horsehead Nebula is located. All right, so before we go back here, let me see how we're doing. I heard some work in my head, and looks like we did get a guide star. We're successfully guiding, looks pretty smooth, and we are on our way. So that's wonderful. All righty. Now let me give everyone the ability to unmute themselves. And let me just, again, welcome everyone to the online viewing session. So now is a great time to help fill a little dead space here, give the throat some time to rest. And, if anyone has any questions or wants to let us know where you're joining us from, welcome. Or we can just enjoy some quiet time. I don't care.
Do all your members have access to this telescope?
The ones that live in Southwest Michigan can. It's only an extra fee, $50 a year to use the telescope. Which, if you've ever rented time on a commercial telescope, it's an extremely good deal. Basically, the $50 a year helps us raise just enough to pay off the yearly subscription fees for the software and all that sort of thing.
So
Hi, I'm
I'm
Ron
sorry?
Meas from Newberg, Oregon, and our skies here are all cloudy.
I think it's moderately clear here, isn't it, Pete?
Horribly cloudy.
Oh boy.
Beautiful last night.
Okay. I've been
Yeah.
too sick. I've been too sick to.
No, the seeing monitor last night, Richard, was it was like we were in Chile.
Oh.
Yeah. We were we were pretty much like 1.3, the average for the whole night.
Wow.
Yeah.
It's great we have a full house here. I know we peaked at 100 there for a while, but now we're at about 98. I don't know how many folks are joining us on the YouTube. We got about 31 people joining us on YouTube. So it's great to have a big crowd for the last online viewing session of the season, because, yep, we only do 4 of these.
Richard,
Yes.
can I access the telescope from Flint?
Flint's a little outside our area. We just kind of keep it to the Southwest Michigan area, kind of our home base.
Okay.
But, because we try not to treat this like a commercial product, because if we did, people probably wouldn't be terribly happy. I'm not trying to, every time I say that, I feel like we have all kinds of technical issues, but we have just enough little glitches here and there to where we don't want to make it a full-blown product, because we know people from not just the state but all over the country and the planet would like to try to use it, especially at the rates that we're charging. compared to the commercial ones. So we just basically make it a local thing for the local club.
Where's local?
Yeah.
Is
B-
local in Kalamazoo?
Yeah, well, I'll give you a map later. It's basically all the counties in southwest Michigan.
Okay.
The only exception we make is Kent County because that's a big base, and we do have a lot of members from the Grand Rapids area as well that are actually a member of both clubs.
Okay.
But as I always like the Kalamazoo Astronomical Society, not only are we the oldest club in the state, we are the biggest club in the state. Oh, and I just heard some bonks in my head, which means the image is done. So everyone go ahead, unmute yourself, and we will release the first target of the night. Are you ready?
Yes.
Here we go. Oh, look at all the wonderful satellites.
Wow.
Bird.
Nice. What?
Beautiful.
So of course you can't avoid the satellites these days. They're just freaking everywhere.
Chris, you want to
The
see a
speaker
picture?
from last month's KAS meeting.
Huh?
Where's the speaker from last month's KAS meeting?
I know. Everyone will get to hear that presentation on the mega constellations pretty soon.
This is the Orion's belt, and it's right below that. Isn't that crazy? I just wanted to show you that. So
So there we go. You can clearly see where the Horsehead Nebula is there. I remember my oldest niece, she's nearly 30 now, but when she was like 3 or 4 years old, I showed her a picture of this region. And I asked her what this looks like, and she goes, horsey. So even little kids know what that is supposed to be. But I do not know who coined the term horsehead.
This luminance?
Pete, did you have something to add?
Well, yeah, is this a luminance?
Yes, this is with the luminance filter.
Okay. Kind of cool. We kind of got a satellite is like actually up and down versus it's a real faint one. It's parallel to the Horsehead.
There's one going up and down.
Yeah.
I see one diagonally there. You mean this one?
Nope. Left. Go to the left. Left. One more. A little more.
Oh, here.
Yeah.
Okay. Yeah. My goodness.
Yeah. You don't see that too often.
No.
Hi, Pete.
Yeah.
Hey, Richard.
Yes.
This is our client. You had stated there was like a luminance filter on that. Is there any other type of filters that are helpful to help see it? I was out last night getting the Orion Nebula's photos last night, and then I was shooting up there. It was very hard to see, really hard to see it, and I wasn't sure if there were special filters that were required.
H alpha would help as well. Usually when we do this up close with the 20-inch, we use an H alpha filter.
Okay, yeah,
But
awesome.
with the Takahashi, I like using the luminance filter for the public because it really pops
Absolutely, that's neat.
in that.
Thanks so much, Apps. That's neat.
Okay, so a little bit of background here. The dark nebula, B33 that forms the Horsehead, it's about 3.2 light years across. That's by my math because no matter how hard I found online, I couldn't find any references to how tall the Horsehead Nebula was. So, I got a background in math, so I did a little trigonometry and I got 3.2 light years. So that's not too bad. That's comparable to the, like the big pillar in M16. And as I kind of alluded to earlier, this is part of the much larger Orion molecular cloud complex that's composed of actually two giant molecular clouds, Orion A and Orion B. The Horsehead is a part of the Orion B complex. And so what makes the Horsehead visible is the background emission nebula here called IC or Index Catalog 434. And this was discovered on February 1st, 1786 by William Herschel. And it's illuminated by Sigma Orionis. The emission and reflection nebula NGC 2023 is located to the Horsehead's lower left, about 15 arc minutes to the northeast. And this was also discovered by William Herschel on January 6, 1785. That is illuminated by HD 37903. Write that down. There's going to be a quiz later, which has a spectral class of B2VE. And I believe it's the
Yep.
nebula here, but this
Yep.
one, this is NGC 2024, the Flame Nebula, which sometimes we do this up close with the 20-inch as well, and that is really awesome. But we're gonna probably save that for next year. I almost did it tonight, but I realized, oh, we just did it last year, so that's one of the ones I try not to repeat every year. But the Horsehead, we try to do that every year because it's awesome. Any other questions or comments about the Horsehead Nebula?
Great TAC image. Really nice.
It is. And don't forget, you'll be able to download the full resolution version of this and zoom in for a little more detail than what we can do here right during the session. All right, so let's go to one of my personal favorite nebulae. Probably even next, this is probably just next to the Lagoon Nebula for me. We're going to do NGC 2244. And let's get crazy with this one. Let's go ahead and do 10 minutes with the H alpha filter, because then it's really awesome. Okay, so off we go.
How big are these filters? 50?
50 millimeter square, yep. Okay, so NGC 2244 is one of the designations anyway for the Rosette Nebula. So this is a much more distant nebula, much bigger actually. It's 5,200 light years away, and it's still kind of bigger than the Orion Nebula in the sky. So if you think the Orion Nebula is big, you ain't seen nothing. It is 4.8 magnitude, but it is very big, 24 arc minutes. So it's not really easy to see with the naked eye, at least maybe from the very darkest of sights. And the nebula is also cataloged as Caldwell 49 from the Sir Patrick Caldwell Moore copy of the Messier catalog of objects that Messier missed. And the open cluster, NGC 2244, is actually Caldwell 50. So there's the Caldwell 49 for the nebula, Caldwell 50 for the cluster in the center. And so of Monoceros's 60 stars, because it's a pretty big area of the sky, none shine brighter than magnitude 3.9. So it's a difficult constellation to find, even though it's right amongst all these showpiece constellations like Canis Major and Orion and Gemini in the sky. But it's hard to see, but there's a lot there. And the nebula has several new general catalog designations. There's NGC 2237 for the nebula, NGC 2238 for the cluster, for a cluster. NGC 2246 are all parts of the nebulous region, while NGC 2244 is the bright open cluster located within the nebula, which is what we're using to find it because it'll put the nebula right in the center. So this was discovered piece by piece. The English astronomer John Herschel, son of William Herschel, found NGC 2244. The German Albert Marth discovered NGC 2238. And the American astronomer Lewis Swift was the first to observe NGC 2237 and NGC 2246. Now, I hope you wrote that down, because don't forget, there's a quiz later. So this covers as much as 4 times the sky as the full moon. So it is big. And it's 3 times as far and 3 times the size of the Orion Nebula. So if this thing were the distance of the Orion Nebula, it would dominate a good chunk of the constellation. And it's located roughly at the halfway point between Procyon and Betelgeuse. Like, I don't have Betelgeuse in the picture anymore, but it is pretty easy to see. And here's kind of the jumbo pocket sky atlas from Sky and Telescope. They have some detailed charts, and one of those is for the Rosette Nebula here. So it's a pretty marvelous region of the sky. Backing up here, if you joined us last month, we did this region with the Takahashi. which we actually never done before until last month. But now we're going back to our classic object, the Rosette Nebula. All right, so let's check in and see how we're doing because we're doing a long one here. All right, so it looks like we probably had the slew to the other side of the meridian. And we just started our exposure there. Oh, the guiding looks kind of shaky. Let's take a peek at that. You can see there's the current configuration of the telescope, but we're going to get that out of the way. And oh dear, it's kind of bouncing around there a little bit. Well, we'll see how we do there. If the image doesn't turn out the way we want, we always have backups from the past we can throw in. So that's not too bad.
Does the Takahashi use the new guide scope?
Yep. Yeah, they both do.
Okay.
All right. So let me go to the chat here and see if people got the question from earlier right. You know, what was the image that I got last night? I'm kind of skipping any possible questions here. I don't see it.
What is the scope? Big? It's a good one.
The guide scope? It's
No, the John Roberts, what is the scope? Takahashi?
Oh, yeah, the scope we're currently using is a Takahashi and FSQ 106 EDX3. The Bortle of the scope, it's about 2, a very strong 2.
Is there a reducer on the?
There is not. There's no reducer on the Takahashi.
You'll need to unlock your iPhone first.
Okay, Pete, was that you?
Hey, you're talking to my phone. Sorry.
Oh, sorry. Nobody guessed the image that I showed up front from last night. Did anyone want to take a guess where all those galaxies were? Come on, it's easy.
Yeah, the Takahashi is a 106, so it's a 4-inch.
It is.
Yep.
Virgo cluster?
That's it. Yeah, it was the Virgo cluster.
I didn't even see it. I just took a educated guess. Thank you.
Well, I just said galaxies, and it's almost springtime, so I kind of goes to go. Oh, okay. So someone asked, "What are the lines?" Hopefully, we answered that one. I'm assuming they're talking about the satellites.
But it didn't ask what
I do.
what satellites.
Oh, well, you'll see them later when you download the images for tonight. So while we're waiting here, did anyone take advantage of High Point Scientific's Mead sale? Anyone buy the last of the LX90s or LX200s? One of our members, I don't know if Tim's here with us, he bought one of the last Coronado refractors, the H alpha scopes. Who maintains the observatory? Oh, that's a good question. A couple of guys. Yeah, Tim got a Solar Max 90. Maybe he'll break out of the box and show it to us later. But the observatory is mainly maintained by Mike Patton, who owns the building. And then one of our other members bought a house basically right next door to Mike Patton, Jim Kurtz. And so both he and Jim, they do a lot of work with the observatory and also with our telescope. One thing we're hoping to do, hopefully as soon as Monday, if it shows up, is we're going to reconfigure the way we image with the 20-inch. I'll fill you in on that later because it's easier if I have a visual.
I saw Gina had a Mead 10-inch, but with a cracked corrector. So I don't know if you can get.
Can't get a replacement.
No.
Yeah, I hope a meteor doesn't go through the 16-inch in the observatory here in town. Otherwise, we're in deep doo-doo. Oh, that'd be really. Just think how much we can sell a telescope that got hit with a meteor. My goodness, just think what we could get.
We need a webcam to record it.
I know. All right, let's go. Let's see how we're doing. Well, yeah, the scene, things got a little rocky there at first, but they settled out. Hopefully that won't affect things too badly, but we'll see how it goes. You can't control the weather.
Is it
Uh,
windy there?
we can go back and check on that. It wasn't earlier. It was very calm, but here's the current all sky camera. Not much has changed yet. We still have Venus. You can see Ursa Major's gotten a little higher, and the nebula has gotten a little more above the mountains there. Over here is the Chiricahua Mountains, Cave Creek Canyon. You can't really see the canyon. You can't really even see it during the day.
Polaris looks a lot lower.
Yeah, it does. It's way down there. So yeah, there's Polaris. We can kind of scroll down there. So there's still that mysterious. Mike Patton told us what this thing is, but I forgot what this mysterious thing on the northern horizon is. Let's just say it's a UFO pad because we don't know what it is. And then way off in the distance, the illuminated house there, that's the house of Rick Benno, one of the year-round residents at Arizona Sky Village. He's helped us a great deal in the past. He has a 24-inch plane wave. This is Mike's new neighbor. I don't
Is
know his
that a
name.
dome to the down and to the left?
Yeah, he has a little dome there. I don't know what he has in there. And this is Mike Patton's house up here. And you can see, for some reason, we can still see the roof when it's rolled off. And even though we've really cracked down on the light inside the observatory, it still looks pretty bright in there, but it's better than it
Been any
was.
new images of birds on the perch?
I've seen them from time to time. I don't always post them on our Facebook page, but if anyone has some free time there, you can go back through our Facebook and you can see some of the birds that I posted over the years. Now the wind has gone up to 4.8 miles per hour. Now it's 4.9, but not too bad.
Yep.
The star is centered now, so I hope that doesn't cause too much trouble with the image, because I sure do love me some Rosette Nebula.
What's the guide scope now?
It's a stellar view. It's the 50 millimeter guide scope from Stellar View.
Oh, okay. Yep.
We actually have one in the observatory here in town too. We actually bought that one for the remote scope because we were having some kind of pointing issue with it, and we were trying to at least get a finder to help us align it, but we never actually needed it, so we just brought it here.
Okay.
Yep, 3C273. That used to be the nearest quasar, but I believe there's one a little bit closer now. I don't remember which one it is.
Hmm.
Is that light pollution on the edge at the 9 o'clock position? Oh, you're probably talking about the all sky camera. So yeah, there is a little bit of light pollution there. Now remember, this is like a gosh, what was the longest exposure I do on this thing now? Like 80 plus seconds. So
Is that coral?
no, I'm not sure what this is. There's not really the only town roughly in that direction I think is Animas, New Mexico, but that's too far away, I think, to really give us this light dome. This might be something more local, like someone's farm or something like that. Just a couple years ago, somebody wanted to put in a large like marijuana plant, I mean, right nearby with bright illuminated bright lights, and we all got together and fought it and won. So yeah.
Yeah, I remember that.
So we'll go ahead and let this trail out here. It's kind of gone on steepward there.
4 seconds.
The anticipation is building. But remember, we do these live. This is not Memorex, folks. These are live, fresh images from the telescope. Some of you really young folks are like, Memorex, what's that? Then you're just too young, and do a search for it on YouTube, and then you'll know what I'm talking about.
Okay, it's not like we're using a hybrid film and we got to run it over to the developer.
That's right. And don't forget, you can order an audio of tonight's program for your 8-track player.
I'm impressed. The cooler is at 29%.
Yep.
What's the temperature outside?
It was about 57 degrees or so, I think.
Ooh.
Heat wave. Here we go. Yeah, it gets hot out there. There we go. Let's hope the stars aren't too trailed there.
I like the preview.
Yeah. What's the benefit of an H alpha filter? Well, hopefully we'll answer that in person here in a short minute. So what happens, you can see there's a bit of a delay here is of course, we get the image in the camera, it downloads to the computer. Maxim does a thumbnail first, which is what you see here. And then it processes a little bit bigger version. But while it does all that, it does some plate solving, which it just finished, 407 stars matched. And now the image is done. Okay. Everybody ready? Here we go. Let's get the oohs and ahs going. Ta-da! That's not too bad.
Ooh, nice.
Nice.
Looks like the stars skipped a little bit. Hey, Jerry, can you mute yourself? You're making all kinds of racket.
Oh, yeah.
Either that or share the chips.
Yeah, that's right.
Pass
Okay.
the Doritos. Nice.
So sometimes this is referred to as the Skull Nebula. At least that's what I've read online. But in my nearly 50 years as an amateur astronomer, I've never heard anyone call it that ever. But there is a Skull Nebula called NGC 246, which I think we just did that for the first time earlier this season. It's a small southern planetary nebula. So the nebula again surrounds the cluster NGC 2244, which is the cluster here in the center, which contains about 100 members, and it formed within the past 5 million years. So for stars, those are really, really young. And the cluster itself is 43 light years in diameter, while the nebula is 130 light years across. It has an estimated mass of about 10,000 solar masses, making it one of the more massive emission nebulae known. And fun fact, if you're joining us from Oklahoma, on April 16th, 2019, the Oklahoma legislature passed HB 1292, making the Rosette Nebula the official state astronomical object. Oklahoma Governor Kevin Stitt signed it into law on April 22nd, 2019. So I don't know how many states have official deep sky objects, but for Oklahoma, it is the Rosette Nebula. What do you think Michigan's state deep sky object should be?
The Cloud Nebula.
A cloud, just a nondescript cloud. Okay, let's get a preview of spring here with the Takahashi. Now, I know a lot of people aren't crazy about just plain old clusters, but what the heck? We're just going to do it. M44.
Ooh. Does it fit?
It fits.
Really?
It ain't that big. It's pretty big, but it ain't that big.
24 is big.
It is. Okay, so M44 is the beehive cluster, or the Persepi. The origin of the beehive name is unknown, and it is one of the nearest open clusters to Earth at just 610 light years away. It is visible to the unaided eye at magnitude 3.7. I mean, the deep sky object, I think, is actually easier to see than the constellation. I mean, it's the only deep sky object that you can say that about. I mean, usually even the Orion constellation is quicker and easier to see than the Orion Nebula, but the beehive is easier to track down first, as opposed to the constellation that it's in. So the Greek poet Aratos called it Little Mist in the year 260 BCE. Hipparchus cataloged it as Little Cloud or Cloudy Star in 130 BCE. Ptolemy described it in the Almagest as nebulous mass and breast of Cancer. Known as Phatni, I think I'm pronouncing that right, to Greeks, which translates Persepi to or manger. Now, the true nature of this object was revealed by Galileo in 1609. The nebula called Persepi is not only one star, but a mass of more than 40 small stars. I'm not sure if he published that in the Starry Messenger, but given it was the year 1609, I would kind of guess it was. So it's, again, not hard to find. You just kind of go from Pollux here to Rigel, maybe with binoculars, and kind of sweep out a line right between the two, and you're sure enough to find it. Again, you'll find the deep sky object before you actually find the constellation because it's so faint and difficult to see. So it's basically just west of a line between Acellus Borealis and Acellus Australis, which is Gamma and Delta Cancri. So if you can see the stars, and you can use those to help you, but again, you'll find the cluster before you find the actual constellation. One of these years we should do M67 because this is like one of the oldest clusters known. This thing's over 4.5 billion years old down here. But we'll talk more about the Persepi here tonight. It's not a terribly showy cluster, M67 anyway. All right, so let's check in, see how we're doing. All right, so we are guiding, and looks like the guiding is a little more smooth now. We're only doing 5 minutes, so that's not too bad. And now let's hop back to the browser. Actually, I'm still on the browser. Oh, looks like Mike Patton may have gotten home from dinner. So those are his car lights. We'll fine Mike $10,000 for blinding us during an online viewing session. So, Jim or Tim Kurtz, if you're listening, please give Mike the bill.
2 full frame cameras.
Yeah, that's right. Two full frame cameras. He has to buy us now. Too bad for him. Let's take a peek at the telescope there.
Isn't there bylaws in the Arizona Sky Village?
Well, you gotta drive home. So okay, there's the current configuration of the telescope. By the way, you can see our logo. We have one just like this in the observatory here at town. This little white screen is our flat screen for the 20-inch. The flat screen for the Takahashi is a little flip flat here.
Yep, flat.
And this little bright thing is a sensor for when the scope is safely parked, because we want to make sure the scope is in its proper position. So when we roll the roof back on, we don't shear the front of the telescope off. That would be bad. We haven't done it yet, thank goodness. And actually, I'm going to turn that off for now.
What's that panel to the right of the flat panel? Large one.
It's one of the control boxes for something or other. I don't remember which. It's been a while since I've been out there, so I don't have everything memorized anymore. I can pop open the, make sure I go through the chat there. Bedtime, what's that? I'm pumped up on steroids, so I can't. No, I've been sleeping pretty good despite the fact they got me on steroids. I forgot to mention that, by the way. I could freak out and have roid rage here at any time, so you never know. So just let that build the anticipation. So hopefully we answered the question, what is the benefit of an H alpha filter? Because I think the Rosette Nebula image explained that pretty well. Because it makes them pop, that's why. Okay, so Tim thinks it's the roof safety control panel, which makes sense. Oop, my notes turned off. How do you get the iPad to stay on all the time? I got to look at that. Okay, let's go back to the browser. There, we'll hit. Let's try to hit reload there. Ah, there we go. Much better. Still got some lines from something. A light from something. We're almost done. We'll just let it work its way out here. So again, yeah, this is the ACP web interface. So that's what's so great about ACP is You don't need any special equipment to control the remote telescope. You just need a web browser, and ACP connects to Maxim and all that runs the telescope. And of course, we have a Paramount, so it also controls the SkyX and our focus program called Focus Max, which we mostly have set up. Still having a little technical issue with that, but it does focus the telescope. That's the important thing. And you can see I'm doing the acquire a single image, but when we do the more fancy imaging, we can do a color series. We can do, through all kinds of various filters. We got 7 filters on our filter wheel. There we go.
You're using 5 now for Focus Max.
What's that?
You're using 5 now for Focus Max, the latest.
Yes, we got version 5. See, look, it fits, Pete.
Never a doubt.
I don't know. I think you doubted. We have it recorded. People heard it.
Small CCD. I mean,
Whew.
edit it
27
out.
Yeah. No, I don't edit. Everyone knows I don't edit. I just chop off the beginning and the end and call it good. 27,329 image stars found. My goodness. Someone's going to have to confirm that later. I would give you a penny for every count, but of course they don't make pennies anymore, so we can't do that.
No.
All right, here we go. Last image of the night or end season with the Takahashi. Ta-da! Now, aren't those pretty? I don't hear any oohs and ahs. Come on.
Oh,
That sounded more pitiful than anything.
Nice, real nice.
Ooh.
Are these older stars?
Now it just sounds fake.
Are they older?
Huh?
Are they older stars?
Mm-hmm. Yep. So the Persepi, or the beehive, has experienced mass segregation. The bright stars are concentrated in the core, while dimmer, less massive stars populate its halo. The cluster's age is roughly 600 to 730 million years old. So that's pretty old for a cluster. And the proper motion should suggest it shares similar origin to the Hyades cluster. The core diameter is 23 light years and contains about 1,000 stars, with a total mass of 5 to 600 solar masses. The total diameter is about 100 light years across. Now, write this down. It contains 68% M dwarfs, or red dwarf stars, 30% sun-like stars, types F, G, and K. The sun's type G, by the way, just FYI. And 2% A-type stars, plus 5 giants and 11 known white dwarfs. The brown dwarfs are extremely rare, probably lost because of tidal stripping from its halo. There are 2 planets orbiting separate stars, both hot Jupiters, discovered in September 2012. So we do know of some planets orbiting stars in the Hyades. Or not the Hyades, the Persepi, the beehive. This thing right here. Pretty cool, huh? Look at all those pretty stars. I know. Clusters just don't turn some people on.
Has
That's
there been
okay.
ever any nebulosity?
Not that I've ever heard. I mean, it's old enough to have, maybe it's not quite old enough to have planetary nebulae yet. I mean, 730 million years old isn't really old enough for even the giants to form, I think, planetary nebulae yet. But I think it could be in the future, just not for us, of course,
Yeah.
because we're just these little momentarily specks. All right, there we go. That's our targets with the Takahashi tonight. So before I switch scopes, let me go into ACP here because I'll forget. And we're gonna set it up for the big scope. Oops, if I can get the enter in correctly. There we go. Alrighty. And so now we're going to hit this little magical script here, and we're going to switch to the big scope. So let me show you what we're talking about. All right, so now we're going to finish up with the main telescope tonight. Our main telescope is the Planewave CDK-20 telescope. So CDK stands for Corrected Dull Kirkham. So a Dull Kirkham telescope, it's basically a compound telescope, you know, kind of like a Schmidt-Cassegrain, but in this case, it has an ellipsoidal primary mirror and a spherical secondary mirror. And in the back, there's a lens group that helps correct the image, hence the term corrected Dull Kirkham telescope. So the primary mirror is 20 inches across. It has a focal length of 3,454 millimeters, and it does have an focal ratio of f6.8. We do not have a focal reducer on this telescope either. And you can see it's all carbon and fiber construction to help limit flexure throughout the night because of, you know, changes in temperature and the tube size and all that sort of thing. So just like on the Takahashi, the main camera is an SBIG STX 16803 CCD camera with the filter wheel. Has, again, same camera, same filter wheel, same filters on the Takahashi. And the autoguider is seen here in its old position. It is now hooked up to a separate guide scope because we have never been terribly happy with the performance of the Innovations Foresight on-axis guider. So if you're a big fan of Innovations Foresight or you work there, no offense, but it just hasn't worked for our setup. So hopefully come Monday, we're going to remove this and we're going to connect the system here directly to the back of the telescope because we just got the new spacer. You should see the first spacer we got from Planewave. That thing is huge. I can see why we did pay $400 for it because it's a big hunk of hardware. And then there's one more custom adapter we're getting from Precision Parts maybe as soon as this week, maybe even Monday. So what supports both telescopes is a software BISC Paramount ME2, which has a 240-pound capacity or 480-pound total capacity with all the weights we have on the end there. So it's a very, very robust mount, and it's worked out pretty well for us.
Wow.
So that is the scope we're going to finish up the night here with. So let me go back and see how we're doing. Sounds like we successfully made the switch. Yep. And enter in our first target of the night. And we'll probably have to slew back to the other part of the sky because this is off in the west now. It is kind of a fall object technically. And we're just going to stick with 5 minutes with the luminance filter. And there we go. NGC 1435. Now, for a lot of folks, you probably don't know what that is offhand, but hey, that's what I'm here for. So NGC 1435 is the Merope Nebula, which is in the cluster the Pleiades. So this is a reflection nebula in the Pleiades star cluster, also known as Tempel's Nebula. It was discovered by the German astronomer Wilhelm Tempel on October 19th, 1859, using a 4-inch refractor. But we do have a 4-inch refractor, but we're going to use a 20-inch to take a picture of it. It is illuminated by the star Merope, which is one of the 7 sisters, and that is embedded in the nebula. It does contain a bright knot, IC 349 Barnard's Merope Nebula. We'll show you where that is here in a second, which is about a half arc-minute wide near Merope. And that object, IC 349, was discovered by E. Barnard in November 1890 using the 36-inch Lick refractor. 15 times brighter than the Merope Nebula, it is incredibly hard to spot thanks to Merope. So I don't think we'll really see it in the image, but if you really look for it later, maybe you'll spot it. And of course, along with the rest of the Pleiades, this thing's about 440 light years away, and it's pretty big, but our chip can just take this in. So it really helps fill up the whole chip. So it's quite spectacular to see with the 20-inch. In fact, 5 minutes may be a little on the long side. So, of course, the object itself is really easy to find. I mean, it's in the Pleiades, but out of those stars in the Pleiades, which one is Merope? So we'll kind of zoom in there a little closer, and this gives you an idea. It's this one here. So here's Aldebaran and the Hyades and Taurus. Jupiter's hanging out over here right now. And we'll zoom in a little closer thanks to one of those close-up charts in Sky and Telescope's Jumbo Pocket Sky Atlas. So here's the star Merope right there. So when a lot of people look at the Pleiades, they see like a little mini dipper. Some people have told me they thought it was the Little Dipper. So we kind of have the Big Dipper, the Little Dipper, and some people do tend to refer to the Pleiades as the Mini Dipper when they first see it, because it looks like a little mini dipper in the sky. So Merope is kind of the lower left of the stars in the little bowl. And I call this line of stars here the bell string. I'm trying to get that to catch on, but still haven't had much luck with that. One day it's going to appear in writing and make me very happy. So there's the Barnard Nebula referred to, but that's going to be tough to spot in the image. But the Merope Nebula here is pretty awesome. Let's see how we're doing. We're underway there. So again, we had to slew back to the other side of the sky. So we're giving the telescope a little bit of a workout here. We'll just let that run there for a bit. Well, I wouldn't say micro dipper because we don't have a mini dipper. We got the big, little, and mini dipper. Maybe there's something else out there we can call the micro dipper. Maybe like M29, but I call that the mini great square because it looks like a little tiny, tiny square. M1 is the Crab Nebula. Tycho Brahe was not the first to notice it. Tycho did discover a supernova called Tycho supernova, but the Crab Nebula was spotted probably first by Chinese astronomers and maybe some Native Americans on July 4th, 1054. So that's well before Tycho Brahe's time. All right, so not too much there on the chat. So we'll go ahead and go back to the screen here. And again, welcome any questions about the club, the scope, astronomy, telescopes. Don't ask, just don't ask me to pick lottery numbers or anything. Because if you win, I get 95%. Did I say 95? I meant 98. Did I say 98? I meant 99.5. Okay, just forget it. Just give me all your money. That's how.
Hi, Richard. This is Kevin from Maine.
Hey, Kevin.
I tried to download the last session's photos, and again, my computer couldn't pick up on the email address, and I was saying there was an error. Can you possibly post something tonight so I can get pictures from the last session?
Absolutely. Let me do that now.
Great. Thank you so much.
Okay, we'll put January images. Boink. There we go. Try that. Whoop! I forgot to update it. That's for tonight. Oh shoot. I should have fixed that first. So don't use that link because it won't work for sure. January 25 OBS. Zip. Hopefully that'll work. I'm not sure. Hang on.
Good question on most favorite object to observe.
For me, my big favorite has always been the Lagoon Nebula. Whenever I get a new telescope, I try to either image it or view it.
Yeah.
I've always been a big fan of the Lagoon Nebula.
Yep.
During the summertime, it's always been my test of how good the skies are too. The more nebulosity you can see, the more the better the night. So it's been one of my favorites for a long time. Oh, dang it. Okay, let's try that. Now that link should work for last month's images, I think. Don't pin me down on that, but well, I got the screen really, really bright. There we go. There. My face doesn't look so blown up now. And I will try to get tonight's images posted as soon as I can, but probably after we're done here, I'm just going to collapse and pass out because I'm doing pretty good though. The throat's holding out better than I thought.
Yeah.
At first,
Very well.
at first there, I thought it was going to be pretty bad because it's sore.
Yep.
I woke up Tuesday morning and I sounded like this. I could barely breathe and talk. All right, there we go. Looking pretty good there. Okay, I think are we done? It hasn't bumped at me yet.
I think for me, my yearly gauge and favorite is M51.
Okay.
Yep.
Yeah, that's a good one too. All right, now it's done. That took a while. I can't wait till we get a faster computer so it does that quicker. All right, here is the first target of the night for the 20-inch. Here we go. Ooh, pretty.
Ooh. Yep.
Damn satellite!
Elon, I'm gonna get you.
That's that roid rage coming to get me. Rawr! Ain't that party?
Focus Max did its job really well.
It did. So in Greek mythology, Merope is one of the 7 daughters of Atlas and Pleione, I think, known as the Pleiades. Merope is a blue-white B-type subgiant, technically a B6 Roman numeral V-type star, so not quite on the main sequence anymore. It is 630 times the sun's luminosity and has a surface temperature of 14,000 Kelvin compared to 5,800 Kelvin for the sun. It has 4.5 solar masses and a radius of more than 4 times that of the sun. The dust and gas surrounding the Pleiades was once thought to be leftover material from the cluster's formation. That's how it was taught to me growing up. But I can remember very vividly when I was a young grad student at Western Michigan University, I picked up the Astrophysical Journal and read a paper that said the Pleiades is simply plowing its way through a dusty region of the Milky Way. And I told our local astronomer, Dr. Kirk Karista, who I'll mention later, and he didn't believe me. I was like, well, read it right here in the Astrophysical Journal. And sure enough, there it was. And now that's pretty common knowledge. But that was a long time ago. So the brightest portion of the nebula surrounds Merope, and Alcyone, which is the brightest of the Pleiades, and it is also visible kind of to the upper left there, kind of probably in the corner there. So you can find that image of the Pleiades we took earlier this season. I'm not sure what month it was. It was either November or December. Somebody can tell me. And you can kind of compare it with this, but this is really up close. Pretty cool, huh? All right. Now we're going to do Mr. Big himself. The one we do every season because it's awesome. And so this one we can do either way. Do you want to do the image with the luminance filter, or shall we do the H alpha filter? Anybody have any preference?
That's 2.
We could do 2?
No. Well, what's the object?
The Orion Nebula.
Ooh,
Anybody have any preference, luminance or H alpha?
H alpha.
Okay, let's do H alpha. Now we'll just do 3 minutes, usually for H alpha. That's really short, but the Orion Nebula is really bright. So yes, indeed, M42 is the Orion Nebula, and I mean the Orion Nebula. Now, of course, we know where it is. The coordinates give us the constellation Orion, and it is fourth magnitude, but here's the really crazy thing. This object is not known to pre-telescopic observers. There's no mention of this nebulous region of the sky at all, which is just amazing. Now, it may have been mentioned in the Mayans' creation myth of the three hearthstones. In the myth, the nebula represents the embers of a fiery creation, but who knows if they're actually referring to the Orion Nebula. It is not mentioned by Ptolemy in the Almagest in the 2nd century, or the Persian astronomer Al-Sufi in the Book of Fixed Stars in 964 CE, even though they charted other patches of nebulosity in the sky. Tycho Brahe in the late 16th century and Johann Bayer 1603 designated it as Theta Orionis. Galileo observed this region in 1610 and 1617, but made no note of nebulosity. It was first discovered by the French astronomer Nicolas Claude Fréby de Pisique on November 26, 1610, and it became designated as NGC 1976 in the New General Catalog. M43, which is the little bright knot here on the sketch by Jeremy Perez. He has a nice website, by the way, so make sure you check that out. It is part of the Orion Nebula, which surrounds what's known as Bond's star. So we technically get M42 and M43 here in the same image because our chip is just big enough to take in the whole thing. And you'll notice the 1,334 light year figure from earlier with the Horsehead Nebula because, again, this is all part of the same complex. So it is easy to find, even though it's apparently difficult for the ancients to find or not even know about. But just go, right down below the belt into the sword, and using a pair of binoculars, you can't miss it. And you can clearly make out the shape of this thing, plain as day, in an ordinary pair of 7x50 binoculars or your little 60 millimeter refractor. So there's a little more detail with Sky and Telescope's jumbo pocket sky atlas. So we were previously up here with the Horsehead. Now we're working our way down here. Last month we did up here, we did the Running Man Nebula, which is always a popular target as well. All right, so this should go pretty quick. Let's scroll back up there. Hopefully I hit it. Yep. And yeah, 3 minutes is really all we need because it is bright. It'll blow out the trapezium region, but still, we're looking for the nebulosity. Let's see. So you mentioned previous online viewing sessions in November, December, January. Do we do other online viewing sessions in the summer? No, during the summer from June to October, we actually shut the telescope down. We unplug it completely. Because the telescope is in someone's observatory, we have not been able to ensure it in any way. And one thing that happens out there during the summer, of course, is the monsoon season. Usually it's not terribly bad out there, but more than one telescope at Arizona Sky Village has been hit and fried by lightning. So we are not taking any chances. And during the summer, we just unplugged the thing. Plus, in June, it doesn't get dark enough out there until just after midnight our time. I can remember one online session we did, early in, like 2020 during the pandemic, because we couldn't have outdoor viewing sessions. So we did do one at from midnight to 2 a.m. And I think roughly 30 members or so actually turned out. But normally we get so busy with the regular observing sessions, that we just don't do these during the summer. And again, the start time would be difficult for those of us, in the Eastern time zone, especially for those of us in Kalamazoo, because we are right on the border of the Eastern time zone. And what would the count for the directional flow of the gas? I think I maybe referring to the Pleiades there, and the flow of the gas would be basically determined by its proper motion, but there also is going to be some resistance from the dark cloud that's plowing through. I mean, if you get online and look for really deep images of the Pleiades, you'll see where you can literally see the thing plow through gas. And that's what will eventually strip a lot of the members clean. Oh, but here we go with the Orion Nebula. So again, let's go ahead and unmute yourself, everybody. I think it's still doing the final processing and star count here. And you'll notice the image is inverted. That'll be a thing of the past as soon as we get rid of the on-axis guider, because the on-axis guider makes all the images in the 20-inch inverted. But that'll go away here soon. So that's why the Orion here looks backwards. Are we ready? Now, I demand oohs and ahs with this one because, it's so awesome. Ta-da!
That is cute. It's good.
Isn't that awesome?
I like mine better.
Yeah, it's really cool.
Oh, nice.
Amazing.
Very good.
All right, so the mass of the nebula is estimated to contain enough material to create 10,000 sun-like stars. Now, it's not going to make that many, but it could if it were very efficient. So there is an extremely young cluster, only 300,000 to 1 million light years of about 300 stars that is emerging from M42, but you really need an infrared telescope to see them. So look for the Spitzer version of this image because you can really see them. So the bright and sharply defined central cavity, which is right here, it doesn't look like it's an open cavity in the image here, but it is, trust me, is called the Huygens region, after the Dutch astronomer Christian Huygens. So the star Theta Orionis is a multiple star system, a cluster in a cluster really, called the trapezium. And I think you can just make them out. Yeah, there it is. There's the trapezium right there.
Yep.
So this is a tight little group of at least 4 stars, but the trapezium actually consists of 8 separate components, A through H, and there's possibly a 9th called X that has only been observed twice by E. Barnard in 1888 and 1889. As far as I know, no one has spotted it since, and of course we have much better images with like the Hubble and Webb telescopes, so maybe he would just have an off night there, but he was a legendary observer, so that's why a lot of people tend to look for this thing, because he knew what he was doing. So the brightest Theta 1c Orionis is magnitude 5.1 and 45 solar masses. And Theta 1c is basically the reason this nebula glows. It is an extremely powerful O-type star. So the projected distances between the trapezium stars is only about 1/3 of a light year. So you can zoom in there and you should be able to see them maybe a little bit better later, unless I'll try to be careful with my post processing so we don't lose the trapezium stars there. And the nebula itself is about 24 light years in diameter. So it's pretty big, but not as big as the Rosette Nebula. But at its distance of about 1,300 light years, it is the nearest big star forming region to the Milky Way, or to Earth. Of course, there are many, many others in the Milky Way, but this is the nearest big one to us. All right, there we go. Now let's go to the last target of the night. We're doing good, really good on time there. Maybe we'll squeeze in a few bonus targets. So we'll see how this goes. I had a little trouble doing this region last night. The stars were turning out funky for some reason, but we're gonna give it a shot. I think I'm just gonna hit that again. There we go. I didn't do it. Okay, so we're gonna do M82, 5 minutes, and off we go. So this is a springtime object. So figured we'd finish up with a springtime galaxy. One of my all-time favorite galaxies. Did I? I think I forgot to share that. Okay, so M82 is the cigar galaxy. So this is our most distant target of the night at 11.4 million light years. And it's a pretty bright galaxy at 8.4 magnitude. I mean, for a galaxy, that's really bright. And it's a really good size to where it fits in the sensor with the 20-inch pretty well. I mean, we could do it with the Takahashi and take in the whole scene with its neighbor M81, but it looks great close up with the 20-inch there. So upon discovering the galaxy in 1774, Johann Bode described it as pale and elongated. Charles Messier observed M82 on February 9th, 1781, and described it as nebula without star. Its light is faint and elongated. Near one end is a telescopic star. Admiral William Henry Smythe, after he retired from the Royal Navy and built his own observatory, characterized M82 as very long, narrow, and bright, especially at its northern limb. William Herschel saw it as a beautiful ray of light. Lord Rosse, the famous Lord Rosse of Parsonstown, who had the Leviathan of Parsonstown, this giant Newtonian, he made note of the dark absorption streaks perpendicular to the long axis. The German astronomer Heinrich de Rest described M82 in more detail. He said it had fine, bright rays, luminous and sparkling, 7 arc minutes long, 100 arc seconds wide, with 2 nuclei eccentrically placed on the major axis. So there you go, a little history of M82. So, excuse me, it's located kind of up by the ear of Ursa Major. So it's in a very popular region of the sky with the Big Dipper here, but it's a little obscured. It's a little in an obscure region above the fainter part of Ursa Major there, but it's not terribly difficult to track down. You can say it's located 2 degrees east of 24 Ursae Majoris, which I just barely have on the screen there. Or it's just over 10 degrees northwest of Dubhe here, or Alpha Ursa Majoris, the brightest star in the constellation. So, you know, just usually your finder scopes are roughly about 10 degrees. So just kind of put the star at one corner and you should start to see maybe a little smudges up there, then adjust it and off you go. Or of course, what most everyone does today is they just type in M82 into your computer. But I try to do it old school for the session there. So you can see M81, which is the target we usually do because it is a little more showy, but we haven't done M82 during a session in quite some time, as I noticed in my log. So I figured instead of M81 tonight, as we often do, let's do M82 to finish out the season there. Before we move on there, let me check, see how we're doing. Oh, we're doing really, really well. Okay, so we'll let that run there. And let me finish out the good old slides here. So somebody asked about this earlier is, of course, if you live in one of these counties in red, which is basically the, majority of counties that our members live in, but we do have members from other parts of the state and even other parts of the country and even other parts of the planet now. But we kind of focus on this region here. So you can join the Kalamazoo Astronomical Society, pay an additional fee, take a little training video, watch a little training video, read the manual, and you can use the remote telescope. We briefly talked about, expanding it maybe to a little larger audience, but we haven't done it yet. But we'll see. That's always still something to hold out with in the future. Oh, let me throw a few links in the chat there while I mention all this stuff to you, because that would make more sense. Here we go. So then there's a link where you can join the Kalamazoo Astronomical Society. Of course, you can just join the Kalamazoo Astronomical Society just to join the club. Of course, we do have mainly members from this region, but we do have a lot of our meetings online, so it's not completely worthless to join if you live outside the area. We do have a $10 supporting membership for those that are out of state. And if you'd like to be notified about the online viewing sessions, you can join the email list. So in the chat, I put the link to go directly to the form to sign up to our OVS email list. Or if you have your phone handy, fire up that camera and scan this little QR code. And that'll take you to the form to fill out. Or you can just send something to our email address, kas@kasonline.org. So, of course, you'll get reminders about the sessions. You'll get the registration and YouTube links. You'll get the links to download the session images and possibly notifications of postponement or cancellation. But we have a perfect record this season. We didn't have to postpone one session. So they've all been good. Now, if you do join the email list tonight, you probably won't hear anything from us until October at the earliest, because this is the last session of the year. But if you do want to join us on Zoom again, or maybe even in person at the Kalamazoo Area Math and Science Center, you can do so on Friday, March 14th at 7:00 p.m. for our March general meeting. That's a little later than usual, but that's at the request of our hosts at the Math and Science Center and even of our speaker, because normally it would be the first Friday, but this time it's going to be the second Friday of the month. And so Dr. Kurt Karista, our resident professional astronomer from Western Michigan University, will talk about stars without nuclear fusion, much of the physics without all of the confusion. So learn about those unusual stars that are hot, but they don't even have nuclear fusion. So that should be an excellent talk. And there's a link in the chat to where you can find out more information and register for the Zoom session if you can't join us in person. If you can join us in person, then you don't have to register at all. Just show up at the Math and Science Center and we'll be there. Now, as I mentioned, starting on April 5th, we begin another season of public observing sessions at the Kalamazoo Nature Center. These are not online, but you can join us in person under the stars. And during the summer, we switched to from the remote telescope to the Leonard James Ashby telescope, our 16-inch Schmidt-Cassegrain in Owl Observatory with a 4-inch Teleview writing piggyback. And of course, members bring out their own telescopes as well. So you can go to the public observing session page and find out the full schedule for the season. And of course, here is the link to download tonight's images. Now, again, don't try the link right now because we're just wrapping up the session here. I haven't even downloaded them yet myself to process them, but normally this season I've been downloading them and processing them on this night. But we'll see how I do with my cold and stuff. But I'm holding up pretty well there. And it sounds like our final image of the night is done. So let's see how we're doing there. And that wraps it up for the slides. All right, it looks good. Are we ready for the final image of the night? There we go. M82. What do you think?
Ooh.
Heck, maybe 5 minutes was a little on the long side.
No.
We'll we'll process that, make it look a little better.
Nice.
So of course you can't see it, but M81 and M82 are separated by about 150,000 light years. And M81 is about 37 arc minutes to M82's south. Which way exactly that is in the image, I'm not 100% sure. So the galaxy is 40,000 light years in diameter. And it's 10 times less massive than M81. And this is a textbook example of what's called a starburst galaxy. A galaxy going through a tremendous burst of star formation. And it's the closest of its type to the Milky Way. So this is the closest starburst galaxy to the Milky Way. So what likely happened is in the past, M81 and M82 probably didn't have a direct collision, but they experienced something called galaxy harassment. So, a big galaxy or comes near little galaxy, or little galaxy comes near big galaxy. Big galaxy disrupts the little galaxy, it harasses it, disturbs all the dust and gas in the galaxy, which triggers tremendous bursts of star formation. And so you can get starburst galaxies through either direct collision or, probably in this case, galaxy harassment, just from the gravitational wake of a big passing galaxy. So, yep, galaxies harass galaxies. And so it was probably triggered as recently as 10 million years ago, which is pretty recent, for a galaxy. It contains about 197 young massive star clusters in its core region. It is 5 times more luminous than our Milky Way and about 100 times more luminous than our galaxy's center. It's once thought to be an irregular galaxy. Again, that's how I grew up knowing it. But 2 symmetrical spiral arms were discovered in the infrared in 2005. So it is the brightest galaxy in the sky in infrared light, but we don't see it that way here. And it is the second largest member of what's called the M81 group, which I believe is like the nearest galaxy cluster to our own local group of galaxies. So there we go, M82. All right, so again, I want to thank everyone for joining us for the final online viewing session of the season. We hope to see you again in November.